Hi, this is John Modlin, Senior Systems Engineer for Profitap here in North America. I've designed this dashboard for the IOTA, a popular network visibility capture analysis sensor that Profitap makes. As you can see, the dashboard is called Communication Protocols. This dashboard simply identifies FTP, TELNET, SSH, and RDP traffic that happens to be going through the network. I'm going to just FTP to any old site here. Doesn't really matter. I just want to see if I get any packets now. The IOTA, it captures traffic and it stores the packets in a database, an elastic database that's on the IOTA inside a 1 terabyte drive. So any packets that are going in and out of it, whether it's in path or in span mode, are stored on the device in the 1 terabyte drive, and the analysis of those packets is stored in an elastic database, which also exists on the 1 terabyte drive. And that information is used for flow analysis to produce graphs and information and things like that. Now, Google is not going to accept my FTP connection because I'm sure they don't have FTP set up. But the point is, the IOTA found my FTP packets and showed me how much of that traffic was going out, the interesting IP addresses involved in the traffic and the layer 4 ports, and how much traffic and what the throughput was to those devices. And the same thing works on TELNET, SSH, and RDP. So I'm just going to use the nested example here, and I'm going to TELNET to Google, which they're probably not going to like. It's not going to work. And we're going to connect. And unlikely, Google has a TELNET server running. Anything they do will probably be SSH, if they even have that, at google.com. So let's see here. We're waiting for this traffic, this capture file to be written out to the drive on the IOTA. The IOTA will examine the file like it does about every 30 seconds when there are connection timed out. We know we tried it. And so I'm looking at every 5 minutes of traffic here. And so we're just waiting for that analysis to happen. And then we should see some TELNET traffic here pop up. Now, it's only because capture files are written out every 60 seconds. So the capture file has to be written out. And we're doing very short tests here. And that's why we're waiting at all, frankly. So there's our TELNET attempt. Here's our client IP, interesting port number, and interesting server IP address. Very, very simple little application here. Okay, so moving on to the next example here. I'm going to connect to Google, which I've changed to be an SSH connection. Let's just check it here. SSH version 2. And I don't expect to get a connection to Google at all. And we should see packets pop up here once analysis is complete of those packets. And it should fail here. Okay, we've got a failure on the connection, which I was expecting, so we can get rid of that. The packets have traversed the network in the last 5 minutes, which is what I'm looking at here. And we're just waiting on the short-term analysis here for the SSH packets to appear. And there's our packets. Took a few seconds there. And we've got a couple of attempts. Again, interesting port, IP, throughput. On the server side, port, IP, and throughput. And this is just a dashboard that I created so that I could track these protocols coming in and out of the network. And I can get a capture file just by clicking on anything that's underlined here, and it will give me a Wireshark PCAP file for that track if I want it. So let's go on to the next example here for RDP. As the SSH traffic rolls out of our 5 minutes here, I'm going to launch an RDP session here, which is popped up over here. And we'll log into google.com. You know, they're not going to like that one bit. But it is going to send RDP packets out in and out of my network for us to test with. And I'm going to show you how I set up this dashboard to do this stuff. We were expecting that, right? No remote desktop to google.com, of course. That would be foolish. And in a few seconds here, we should get our RDP packets popping up. And there we have packets for RDP traffic, the interesting IPs and ports and everything involved down here in that traffic. So how did I do this? So up here, I used Lucene search filters to define all of the traffic that I wanted this dashboard, this whole dashboard, to be limited to see. So using the Lucene search filters, I can set up a series of filters to do all these limitations. So I'm just going to go through them real quickly here. I've got protocol name FTP, or protocol name FTP control, or L4 destination port 20, port 21, port 22, port 23, or 3389 for RDP. I've got protocol name SSH and protocol name SSH v2. So that traffic is able to filter down into this dashboard. Now for each one of these widgets, I simply identified the particular protocol for this widget. So I'm going to edit the widget. Come in here, I've looked for the sum of total bytes, for what query here, for the protocol name, FTP, or protocol name, FTP control, or L4 destination port 20, or port 21, because you can't get either one of those ports on FTP. So each one of those shows the independent protocol numbers, while down here I'm presented with everything that passes through the Lucene search filter. And I set up a little time widget here just because I thought it'd be nice to see while I'm working. And I can also use the display filters that are built in to the IOTA if I want to, or the Berkeley packet capture filters if I want to get a capture file of all the traffic together. I don't have to use Berkeley packet filters. I could just get everything, but it's an option here. You might notice also there's a little data right here. Each one of these blue lines is a spark graph. So you get examples of the traffic by protocol in here on their own individual spark graphs, which I thought was kind of a nice little added feature also. Well, that's all I wanted to show you just quickly here in this little video. And I have some more little videos I'm going to do on setting up dashboards. And so I hope you enjoyed it. And